Today we're going to conduct a rigorous scientific examination of the Glubinaya Systema Razvitia, or in-depth development system, developed by Dmitry Ustinov. We'll analyze the claims, examine the evidence, and determine whether this system has scientific merit. First, let's understand what this system actually is. The Glubinaya Systema Razvitia, abbreviated as GSR, is a purported methodology for human cognitive and physical development created by Soviet scientist Dmitry Ustinov in the 1970s and 80s. This system emerged during the Soviet era when there was significant interest in enhancing human performance for military and space exploration purposes. The system claims to enhance cognitive abilities such as memory, concentration, and problem-solving, as well as physical performance metrics like endurance and reaction time. The theoretical foundation rests on concepts of neuroplasticity and adaptive training, suggesting that specific exercises can restructure neural pathways. The system proposes a holistic approach, claiming that exercises targeting the brain can produce measurable changes in both cognitive and physical domains. Let me pose an important question. What are the core components of this system? Let's examine the main elements that Ustinov proposed. First, rhythmic breathing exercises. These involve specific patterns of inhalation and exhalation, allegedly to optimize oxygen delivery to the brain. Second, visual perception training. This includes exercises designed to expand peripheral vision and improve visual processing speed. Third, memory pattern recognition tasks. These are progressive exercises that increase in complexity to challenge working memory. Fourth, physical coordination drills that synchronize movement with cognitive tasks, purportedly strengthening brain-body connections. These four components are designed to work synergistically, with each element supposedly reinforcing the others through what Ustinov called integrated neural activation. Now let's move to the critical part of our analysis. We need to examine whether these claims hold up under scientific scrutiny. The first major claim is that GSR enhances neuroplasticity beyond normal levels. What does the evidence say? We know from decades of neuroscience research that neuroplasticity is absolutely real. The brain can form new neural connections and strengthen existing pathways through practice and learning. However, there are no peer-reviewed studies that specifically validate the GSR methodology. This is a critical gap in the evidence base. While GSR itself lacks validation, similar methods like cognitive training programs and meditation have shown measurable effects on brain structure and function. Here's the comparison. On the left, we have proven methods with robust evidence. On the right, we have GSR claims that remain unvalidated by independent research. The second claim is that GSR produces accelerated cognitive development compared to conventional training methods. The primary problem is the complete absence of controlled studies. Without randomized controlled trials, we cannot establish causation. There are anecdotal reports from practitioners, but anecdotal evidence is scientifically insufficient. We need controlled experiments with proper comparison groups. Even if improvements are observed, confounding variables like placebo effects, increased practice time, or selective reporting cannot be ruled out without proper study design. This raises an important question. What would proper scientific validation actually require? Let's outline the necessary criteria. First, we need randomized controlled trials with adequate sample sizes. Participants would be randomly assigned to GSR training or control conditions. Second, double-blind methodology, where neither participants nor assessors know which group received which intervention, to eliminate bias. Third, standardized objective measurements of cognitive and physical performance using validated assessment tools. Fourth, long-term follow-up studies to determine whether any observed effects persist over time or fade away. Fifth, and critically important, independent replication by researchers not affiliated with the system's developers. This diagram shows the complete scientific validation process. GSR has essentially only completed step 1, hypothesis formation, without progressing through the remaining crucial steps. Let's examine the proposed physiological mechanisms. Does the theoretical framework make sense based on our current understanding of neuroscience? Regarding breathing exercises, we know that controlled breathing can influence cerebral blood flow and autonomic nervous system activity. This part has some physiological plausibility. Cerebral blood flow is proportional to partial pressure of carbon dioxide in arterial blood. Breathing patterns can modulate this relationship. However, the claims made by GSR exceed what breathing exercises alone could realistically achieve based on known physiology. For visual training, we know that the visual cortex exhibits plasticity and can be trained. Professional athletes and pilots undergo similar training with documented benefits. Memory pattern recognition tasks can strengthen hippocampal function. This is well established in cognitive neuroscience literature. Where GSR becomes problematic is in claiming that integrating these elements produces synergistic effects beyond the sum of individual components. There's no mechanistic evidence for this synergy. Now let's discuss the red flags that should make us skeptical about GSR claims. Red flag number 1. The complete absence of peer-reviewed publications in reputable scientific journals. This is highly unusual for any legitimate scientific breakthrough. Red flag 2. The methodology is often described as proprietary or secret. Science advances through open sharing and scrutiny, not secrecy. Red flag 3. Extraordinary claims without extraordinary evidence. Carl Sagan's principle applies here. Claims of revolutionary cognitive enhancement require robust proof. Red flag 4. Virtually no independent verification by researchers outside the system's immediate circle of proponents. Red flag 5. Commercial exploitation and training programs being sold without establishing a scientific foundation first. These characteristics align more closely with pseudoscience than with rigorous scientific methodology. We must be cautious when encountering systems with these features. Let me pose another critical question. Are there any legitimate aspects to GSR, or is it entirely without merit? The answer is nuanced. Some individual components do have scientific support, even if the integrated system itself lacks validation. Breathing exercises for stress reduction and improved focus are well documented. Techniques like box breathing are used by military special forces. Cognitive training can improve specific skills, though the transfer to general intelligence is limited. This is supported by meta-analyses of cognitive training studies. The integration of physical and cognitive training has demonstrated value. Dual-task training is used in rehabilitation and sports science. What remains questionable is whether the specific GSR methodology offers advantages over existing validated approaches, and whether the extraordinary claims are justified. Let's compare GSR with evidence-based alternatives that have been scientifically validated. Cognitive behavioral training has extensive research support. Programs like Lumosity and Cognifit have been studied in controlled trials, with mixed but documented results. Aerobic exercise has robust evidence for enhancing cognitive function, particularly executive functions and memory. The mechanisms involve increased neurotrophic factors. Mindfulness meditation has been extensively studied with neuroimaging. It shows measurable changes in brain structure and improvements in attention and emotional regulation. Sleep optimization may be the most underrated cognitive enhancer. Research consistently shows that adequate quality sleep is crucial for memory consolidation and cognitive performance. This table compares GSR with evidence-based alternatives. Notice that the alternatives with the strongest evidence are also the most accessible and lowest cost. We must also consider the powerful role of placebo effects in any cognitive or performance enhancement program. Research shows that expectation alone can influence perceived performance. If people believe a program will help them, they may report improvements regardless of actual efficacy. When people invest time and money into a program, commitment bias makes them more likely to perceive benefits. This is a well-documented cognitive bias. Simply paying more attention to cognitive tasks and practicing regularly will produce improvements. This doesn't validate the specific methodology being used. The observed effect equals the true effect of the method plus placebo effects plus benefits from increased practice. Without controlled studies, we cannot separate these components. This brings us to the central question: does GSR actually work? Let me provide a scientifically honest answer. The scientifically honest answer is that we cannot definitively say whether it works without proper controlled studies. What we know is that individual components, like breathing exercises, visual training, and memory tasks, have established benefits based on separate research. What we don't know is whether the specific GSR integration method adds value beyond practicing these components separately or using established programs. The most likely scenario, based on current evidence, is that any benefits people experience come from increased practice and attention rather than from unique properties of the GSR system. In conclusion, the system lacks the scientific validation necessary to support its extraordinary claims. This doesn't prove it doesn't work, but it means we have no reliable evidence that it does. Let me provide recommendations for thinking critically about programs like GSR. Always ask for peer-reviewed evidence published in reputable scientific journals. Testimonials and anecdotes are not sufficient. Be skeptical when methods are kept proprietary or secret. Legitimate science is transparent and open to scrutiny. Consider evidence-based alternatives first before investing in unvalidated programs. Why choose uncertain methods when proven ones exist? Remember that extraordinary claims require extraordinary proof. Revolutionary breakthroughs don't remain unvalidated by the scientific community for decades. Recognize that cognitive biases affect how we assess our own improvements. Subjective feelings of enhancement may not reflect objective changes. Use this framework to evaluate any cognitive enhancement program. Good science has these characteristics on the left. Warning signs appear on the right. Let me provide a final scientific assessment of the Glubinaya Systemma Razvitia. The system combines elements that individually have known benefits according to established neuroscience research. However, the specific integrated methodology lacks empirical validation through controlled scientific studies. The claims made about revolutionary cognitive enhancement exceed what current scientific evidence can support. There is no independent replication or peer review of the purported effects in scientific literature. The verdict is that GSR remains unproven and is likely not superior to evidence-based alternatives that are more accessible and better studied. If you're interested in genuine cognitive enhancement, better options exist with solid scientific backing. Regular aerobic exercise, at least 150 minutes per week, has strong evidence for cognitive benefits across the lifespan. Quality sleep of 7 to 9 hours nightly is essential for memory consolidation and cognitive function. Engaging in lifelong learning and novel challenges maintains cognitive reserve and promotes neuroplasticity. Social engagement and maintaining meaningful relationships have protective effects on cognitive function, particularly in aging. Proper nutrition, particularly adequate omega-3 fatty acids, supports brain health and cognitive performance. In closing, this case study illustrates the importance of scientific skepticism and critical thinking. Science advances through rigorous testing and replication, not through anecdotes and testimonials. The burden of proof lies with those making extraordinary claims, not with skeptics to disprove them. Consumer protection in the marketplace of ideas requires scientific literacy and the ability to evaluate evidence. Let me summarize our scientific analysis of the Glubinaya Systema Razvitia. GSR is an unvalidated cognitive enhancement system originating from Soviet-era research programs. While individual components have some merit, the integrated system lacks scientific validation. There is no peer-reviewed evidence in reputable journals supporting the extraordinary claims made about this system. Evidence-based alternatives like exercise, sleep optimization, and mindfulness are readily available and well-studied. Applying critical thinking and scientific literacy helps protect consumers from unvalidated programs. Always demand rigorous scientific evidence before accepting claims about cognitive enhancement or any health intervention.